today we're taking a little bit of a detour. Before we get into the next section, I want to talk about domains. So this is just kind of something extra that we're throwing in because the next section we are finding a lot of different domains. So I want to take a little bit of time and practice that skill before we need it tomorrow. We have found domain quite a bit by looking at graphs. And so from the graph, when I talk about domain, what am I asking you to do? What is a domain?
List of all x points.
Okay, telling you what possible values x can be. When we're looking at a graph, we go from left to right, looking at the x values that were hit. So today, we are going to try to decide a domain by looking at just an equation. Or an expression. Things to remember when we're talking about domains. When we have a fraction, what do we have to worry about in a fraction? What can't happen in a fraction? Let me ask that. Oh, that could happen. We have like 5/2. We could do that. There's one thing we can never do. And if you try to put it in your calculator, it even gives you an error message. We can't divide by 0. So in a fraction, the denominator cannot equal 0. Right? It doesn't matter what the top of the fraction is, but no matter what, the bottom of the fraction cannot be 0. Okay, second thing we have to worry about has to do with radicals. Now we know from even the graphs, like when you did the cube root, we could put it in negatives, couldn't we? And positive. So that cube root graph went everywhere. So it's actually only even roots that we have to worry about. So by even roots, I'm talking about a square root, 4th root, 6th root, and so on. Alright, if you have an even root, what do we have to worry about?
Can't be a negative.
Okay. The radicand, or the thing under the radical, always has to be greater than or equal to 0. And we saw that when we graphed the square root, it started at 0 and went on after that. So we didn't have anything less than 0 that we could plug in. For our purposes, right now, this is all we have to worry about. There are some other functions that have weird domains, like when we're talking about trig functions, or which we won't do in this class, logarithms. When we get to those, their domain is a little bit different. But with the functions that we've encountered so far, these are your only 2 rules for your domain. Everything else has a domain of negative infinity to positive infinity. So if you don't have a fraction, you don't have an even radical, your domain is everything. You can plug in whatever number for x that you would like. So when we look at these problems and try to identify the domains, I'm going to ask you, do we have a fraction? Do we have a radical? And then we'll base our domain off that. Let's look at a problem. Alright, so number 1. Can you guys see that? F of x equals 3x squared plus 2x minus 1. Do we have a fraction? No. Do we have an even radical? We have an even power, but do we have an even radical? No. So what's my domain? So all we're doing on these problems is listing the domain. So this one you can plug in any number that you would like. Number 2. F of x equals x over 2 plus 1. Do we have a fraction? Yes. In a fraction, the denominator can't be 0. So that means 2 can't be 0. Does that ever happen anyway? No. Do we have an even radical? No. So what would my domain be? We have a fraction, but the bottom's never 0, so our domain is everything. Alright, let's look at this. F of x equals 2x over x minus. Right. Do we have a fraction? In a fraction, we know the bottom, the denominator, cannot be 0. So x minus 3 cannot be 0, so that means x cannot equal 3. Do we have any even radicals to worry about? No. So my domain is everything except 3. So if I'm going to give interval notation, that means it's everything smaller than 3. So negative infinity to 3 can't equal 3, so that's a parenthesis. Union, parenthesis, 3 to infinity. Number 4. Do we have a fraction? No. Even radical? Yes, because it's a square root. So with even radicals, the radicand, the thing under the radical, has to be greater than or equal to 0. So that means x has to be greater than or equal to 1. How would I write that in interval notation? It's starting at 1 because of equal to, we get a bracket, and it's everything greater than that. So far, so good? Let's look at this one. Even radical, so the thing under the radical, our radicand, greater than or equal to 0. So we add the 3, so 2x is greater than or equal to 3. Divide by 2, so x is greater than or equal to 3 halves. Just as a side note, dealing with these inequalities, what do you have to remember if you multiply or divide by a negative? Flip your inequality. Okay. So greater than or equal to 3 halves starts at 3 halves with a bracket, and it's everything larger. So paths to infinity. Number 6, we have a fraction. So what do we have to worry about in a fraction? So what can x not be? Just like when we solved quadratic equations, if you had two parentheses multiplied that equal 0, you could set each of them equal to 0. So if we look at this, we actually get two numbers that x cannot be. Now, different ways of writing this, if you wanted to think about this on a number line, it's telling me it's everything smaller than 1, everything between 1 and 2, and everything bigger than 2. So the interval notation is kind of a little lengthy here. It's negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. That's great, that's the ideal answer. I will allow you, if it's more than one number that x cannot be, I will allow you to just say x cannot equal these things. So on this one, I would accept either of those answers. Now the previous one, when we had x cannot be 3, I do want that written as an interval. If it's just one value x can't be, it's not too difficult to write that interval. When it's more than one, it becomes a little bit longer, so you could give me either. All right. I want you guys to try a couple. So number 7, we have a fraction, but the denominator of that fraction is just a 2. Does 2 ever equal 0? Nope. So what's my domain? All right. Number 8, we have a radical. So the radicand, the thing under the radical, has to be greater than or equal to 0. The only thing actually under the radical here, though, is the x. That plus 1 is on the outside. So it means x is greater than or equal to 0. We ignore the 1. So my domain is just bracket 0 to infinity. Thinking about transformations, what would that plus 1 do to your graph? Shift it up. So it would change your range, not your domain. All right, number 9. So if I look at this one, my radicand, the thing under the radical, greater than or equal to 0. Does that factor nicely? No. What would you do then? Okay, so you subtracted the 2. What happens if you try to do the square root right here? It gives you an imaginary. So, do we have to worry about that? It's saying the only thing that would make it equal 0 is an imaginary number, right? When you square something, are you getting a positive or a negative? Positive. So x squared is positive. When you add 2, it's still positive. So what this is saying is no matter what I plug in, it's always greater than 0. So what's your domain? Alright. This one. It's a fraction, so what do we know? So my denominator cannot equal 0. How would we factor that? It's a squared. Sorry. It's tiny. So the denominator can't be 0. What could you do to both of these? What can we take out? That leaves us with x minus So if you set each of those equal to 0, x cannot be 0 or 4. Since it's more than one value, you could leave it like this if you wrote it as interval. Everything smaller than 0, everything between 0 and 4, and everything bigger than 4. Oh, you're fine. Come on.
The lesson and only solve that one.
All right, why don't you guys try these two on your own?
4x minus 9 is greater than equal to 0.
Good.
And x is greater than 9/4.
And how do you write that?
Bracket 9/4 to
Mhm.
x is
Good. What about number 12?
x is greater than 0, which is good.
Okay, we kind of have a couple things going on here. We have a fraction, so we know the bottom can't be 0. And we also have a radical, which means the thing underneath the radical is greater than or equal to 0. So my thing under the radical is x, so that's greater than or equal to 0. Since it's on the bottom, though, we know that the square root of x can't be 0. So we have to put these together. This, if you square it, you get that x can't be 0. So this one says it's greater than or equal to 0, but this one says, well, it can't be 0. So it's just 0 to infinity. You have to take out the 0. It's a parenthesis because it makes the denominator equal to 0. Does that make sense? We have 4 more. Once you try the next 2 on your own, we'll look at the last 2 together. So we have a couple things going on in 13, don't we? We have a fraction, so we know the denominator can't be 0. We have an even radical, so the thing underneath the radical is greater than or equal to 0. We have to put these together. So this says x can't be -2. This one, if you subtracted your 1, you end up dividing by a negative, which flips it. So you get x is less than or equal to 1. So think about what this says. Less than or equal to 1. Everything's smaller than 1. But this one can't be -2. So you are looking for the overlap here. When you write your interval, you're giving me the pieces that make both of them true. So everything less than 2 works for both of them. So we could say -infinity to -2. But -2 does not, so we have to take that out. And then everything from -2 to 1 would work. But the 1 would have to get a bracket. So the -2 gets parentheses because it did not work for both. But the 1 did, so it gets a bracket. Is that one okay? Right, because it only worked for one of them, not for both. So it's kind of like an and. When you think about like the compound inequalities, it's like an and. You're only taking what's true on both of them. Okay, number 14. There's no fraction. We have a radical, but the radicand is just a 2. And isn't that always greater than or equal to 0? So what's your domain? Alright. Last 2 problems. Alright, so we have a fraction. We know in a fraction the denominator cannot be 0. We also have a radical, and we know that when we're dealing with these radicals, the radicand is greater than or equal to 0. So to solve both of this, subtract your 3, so x can't be negative 3. This one we get x is greater than or equal to 1. So we have to put those together. Drawing the number line is completely optional, but if it helps you do it. Greater than or equal to 1 looks like this. Not equal to negative 3 is everything except negative 3. What's my overlap? What works for both of them? If you're greater than 1, can you equal negative 3 anyway? No. So it's just that bracket 1 to infinite. Number 16. We have a radical, so the thing underneath greater than or equal to 0. What do you want to do? Okay, if we subtract over the 5, then we have to divide by a negative 2, which flips my inequality. So how would we write the interval?
Negative 85x with the
So this is all we are doing today, just talking about looking at these functions and finding their domains. If you look on Google Classroom, there is a handout with domain practice. Now, the front side is actually these 16 examples that we just did. So your assignment is the back of that handout. Okay, so it's a 2-page handout. Page 2, it's 12 problems. That's your homework.